Sequences. Don't let the title fool you until, or upset you or scare you until you see what a geometric sequence is. In fact, we saw one yesterday. We saw one that was multiplied by. I mean, I'm giving it away. So the note here acts like it's going to be a big surprise what's about to happen here. I'm already telling you what's going to happen. Geometric sequence. First one, 4, 8, 16, 32, 64. The idea is, if it's geometric, you take each term and divide it by the previous term to find out if it's multiplying by something all the way along. So you'd go 8 divided by 4, and I get 2. If I take the second term and divide by the first term, I get 2. Someone multiplied by 2 to get the second term. Does it happen every time? Let's check again. 16 divided by 8. Oh, that one's 2 as well. When this happens, it's called a geometric sequence. You're multiplying by 2 every time. Question? Probably. Next one, 32 divided by 16, 2. 64 divided by 32, 2. When this happens, and if you did yesterday's homework, you're like, oh, this happened yesterday. But we had to subtract to get the common difference. Now, this kind of sequence, and it's the only other type of sequence we're going to look at, it's either arithmetic, it goes up by the same amount every time, or it's geometric, it multiplies by the same thing every time. Or it's none of those, and we may have to identify it and go, this one is not arithmetic or geometric, but we won't have to do anything with it. Yeah? There's 2 more examples doing the same thing. Yeah? For geometric, here's how you decide if it's geometric. You take the second term, and you divide it by the first term, and it looks like the multiplier might be -2. And yes, I know some of you can just look at them and you don't have to do the division. That's great. If you can just look at it and you can see what the multiplier is, I love it. But if you can't, this is the procedure. You take the third term, divide it by the second term, I get -2. I'm really starting to feel like this thing's geometric because it's being multiplied by the same amount every single time. -40 divided by 20, -2, 80 divided by -40, -2. That one is also geometric. It's being multiplied by -2 every single time. Last one, 243 divided by 729. If you type that in your calculator, you either get 1/3 or 0.333 repeated. Still considered a geometric sequence as long as I get the same every time. It just happens that it's a fraction this time. Should I use the fraction or the decimal? Well, that depends on how accurate you want to be. Most times here we actually just go to the decimal. That's fine, but know that that's out there. We may have to use the fractions sometimes. Is it the same every time? You type in 81 divided by 243, and you get 1/3, or you get 0.3 repeated. Certainly looks like somebody multiplied by 1/3 every time. You could say they divided by 3 every time, but that's the same as multiplying by 1/3. And it happens every time here. 27 divided by 81 is 1/3, and 9 divided by 27 is 1/3. And I've already given it away. This note acts like it's going to be a big surprise what's happening, but I've already given it away. What do you notice about the ratios for each sequence in the above table? They were equal in each row. Hi there. Oh, thank you very much. I heard you. I heard clip, 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 and I was like, oh, something's happening. Each of these sequences is said to have, what was it called yesterday? Common difference. This one's called a common ratio. Good. And instead of using a D, we'll use an R. So, and then here's the fancy box. A geometric sequence is a sequence that has a common ratio. between each term. In other words, each term is multiplied by the same value to get to the next term. The common ratio can be positive, could be negative, or it could be a fraction or a decimal. And the common ratio can be found by taking any term and dividing it by the previous term. Oh boy, does that ever encapsulate, review, explain exactly what's happened so far. So there's your study notes. Like, I don't know what's happening with these geometric sequences. Right there exactly tells you what's going on there. Any questions so far? More time to put a box around the important information there? No, you're good. Woo. Oh, I wanted that to go better than it did. Oh. First question. Is this a geometric sequence? Is the first one a geometric sequence? Maybe you can tell by inspection. Multiply by 2, multiply by 2, multiply by 2. Yes, it's a geometric sequence. Technically, if you weren't sure, you'd have to take each pair and divide to see if it's the same every time. I'm not setting up to trick you. You can look at it and say, okay, yes, it's multiplied by 2 every time, so yes. Common ratio of 2. How about the second one? Yes, how can you tell? It divides by, he can do it in his head. And sometimes the numbers will be nice enough that you'll be able to do it. Other times you won't be able to. Other people have to go 54 over 162 is 1/3. 18 over 54 is 1/3. 6 over 18 is 1/3. 2 over 6 is 1/3. You may have to go through all those steps to convince yourself that it's being multiplied by 1/3 every time. But yes. Common ratio of 1/3 this time. How about the third one? Is it a geometric sequence? No. 4 divided by 2 is 2, but 6 divided by 4 is 1.5. No. No common ratio. The only other question you'd ask yourself with this chapter then is, well, is it arithmetic? Does it go up by the same amount every time? And the answer is yes. So this question doesn't ask me to do that, but if you look, this is actually an arithmetic. So that's the only other type of sequence we're doing in this chapter. Okay? That's yesterday's. Questions there? Well, geometric, anybody who's thinking biology, chemistry, those type of things, geometric sequences have a direct application in biology. So I feel like I should get distracted for a second and just do a little biology example so you can see what's going on here. A bacteria culture was studied and it was determined the bacteria split into 3, then into 9, then into 27. And this is exactly what bacteria do, by the way. They just split. And they can split by multiples of 2, multiples of 3. It really depends on the biology of the situation. But essentially, here's the sequence. We started with 1 bacteria, which split into 3, which then split into 9, which then split into 27. Is that a geometric sequence? Yes. Common ratio of 3. And somebody might say, well, I didn't really need your sequence. I know you wrote it all out for us, and that was very nice of you, Mr. Todd, but I didn't really need the sequence to know that this was geometric. The description of the situation told me it was geometric. Splitting into 3. It was multiplying by 3 every time. So it says find a formula for any term. And this is what we had yesterday. It was a very powerful formula to use. And so what's happening here is, let me just walk through this table again here. For term I'm going to do n and Tn. Term 1 was 1. Term 2, how do we get to term 2? See, if you want to figure out the formula, you can't just write the numbers. You got to go, how did I get there? Yes, we divided there to get 3. So to get from 1 to 3, we take 1 and times 3. Okay? And yes, I know that's 3. I wrote that up there. I know that's 3. But if I'm trying to figure out the formula, I got to think out what am I actually doing to get that term. So the third term, I go 1 times 3, but then I multiply by 3 again, which if you want is 1 times 3 squared. I'm really on my way to getting the formula here. I'm almost there, but I'll do a couple more just to convince you. Oh, I scrolled down as far as I can go. The fourth term, 1 times 3 times 3 times 3 again, which is 1 times 3 cubed. Now I'm ready to do the formula. Take your 1 and multiply by 3. How many times? Here's the hint. For the second term, I multiplied by 3 once. It's the n minus 1 again, same as yesterday. So don't let that n minus 1 mess you up. The n minus 1 is there because you only multiply by 3 one less time because you didn't need to multiply by 3 for the first term, just on the second term. Now I could get anything. You're like, I want to know how many bacteria there's going to be in 6 hours or 6 days. You can do whatever now. Powerful. Building a table like this, yes, it gets right answers. Yes, it's easy to understand. No power whatsoever to get answers. Even better, you say, when will I have 40 million bacteria? You could put the 40 million over there, and you could solve for it. Yeah. Questions there? You got one page front and back, right? We've already done front. There's a little surprise at the bottom, though. I don't know if I gave enough room at the bottom of the second page, so it might not be as good as it looks. So in a geometric sequence, the first term is represented by the letter A, the same as we do with arithmetic sequences. And the common ratio is we use the letter R. R for ratio. So the first term is A. The second term is A times R. Third term is A times R, which is AR squared. The fourth term is A times R times R times R, which is AR cubed. Now I'm going to do the formula. Here comes the formula. Tn is A times R. It's the pirate question here now. R. I don't know how many R's. I do know how many R's. How many R's to get to the nth term? For 3, I had to do 2.
So the n minus 1.
It's the n minus 1 again.
That's it.
Start with the A and multiply by the R n minus 1 times. Anyone laugh at my pirate joke? No? Marley? No? R. Wasn't really a laugh, but that's okay. I'll take wow. Sarcastic wow, though, was it? Yeah. Wow. More time there? Oh, it's all in a fancy box for you. Look. Fancy box. General term. This is the formula for geometric sequence. Tn equals AR n minus 1. A is the first term. R is the common ratio. N is the term number. And Tn is whatever term we're talking about in the question. I'm sorry. On the photocopying, I didn't really clue in that they didn't give you space down there on the bottom of this handout. So you might need a separate page to do these questions. I got to do examples 1, 2, and 3. I gave myself room, but unfortunately, I didn't give you room. Yeah? I got to do what do I do? 1, 2, 3 examples. Develop a formula for the nth term of the following sequence and use it to get the 8th term. This does all that in one. You're supposed to have done yesterday's homework and know essentially what we're trying to accomplish here. Different formula, same basic procedure. The formula for geometric sequences is Tn equals ARn minus 1. So my job is just to find A and R. What's A? 4. It's just the first term. Yeah, that's the same as yesterday. To get the R, I take the second term and divide by the first term. Now, do I have to do all of them? No, not this time, because it said these are geometric sequences. So I don't have to worry that maybe it's not a geometric sequence. In other questions, you might have to first verify that it is a geometric sequence, but here I can get the R that quickly, and just that fast, I've got the formula. Tn equals 4 times 3 n minus 1 times. There, that's the formula that will allow me to do the work that they want me to do. What work do they want me to do? Oh, find the 8th term. So I go T8 equals 4 times 3 to the 8 minus 1, which is 4 times 3 to the 7, which you'll need your calculator. Can I do this in my head? I don't even know. 3, 9, 27, 81, 243, 729, 2187. 2187 times 4, I don't think I can do it. 8800 minus 52, 8748. That's my best guess.
Yeah.
Is it right? All right.
That was
It's just 4s and 3s. Let's not give it too much credit. But I pause for questions. I'm not trying to rush it. But again, if you either really understood yesterday's lesson or you did some of the practice, it's just a different formula. I'm doing the same thing. It's just plugging things into a different formula. And yes, it's a little different because it's got an exponent on it, but it essentially is the same procedure. So here's B. Do it a little slower, just in case someone's having trouble with this. The A is the first term in the sequence. To get that A, you just look at the sequence and write down the first number there. R is the common ratio, which if it told you it's a geometric sequence, to find the common ratio, just take the second term and divide by the first term. Here I get negative 1/2. So this is a pretty good example because it's showing how to deal with negatives and with fractions all at the same time. There. Formula. Whammo. What do they want me to do? They want me to find term 8. Now, I'll try and do the fraction work. I know some of you are just hammering these into your calculator, which if you're thinking of going on to advanced functions, calculus, those type of things, you better have your fractions down a little better than that. You got to get to the point where you're not intimidated by negative 1/2 to the 7th. And let me help you with that if you are a little intimidated by that. This would be negative 1 to the 7th over 2 to the 7th. Negative 1 to the 7th is just negative 1. 2 to the 7th is 2, 4, 8, 16, 32, 64, 128. So I get negative 100 over 128, which I can reduce without my calculator. Divide them both by 2. Divide them both by 2. Negative 25 over 32. In the meantime, did anyone hammer it in their calculator to make sure? Is it right? No joke. If from here you're going to go on to data management, you probably can rely on your calculator to handle the fractions. The fractions don't get out of hand in that course. From here you're heading to advanced functions. You better not be that reliant on your calculator. Be able to, in a pinch, you better be able to handle this situation. Yeah? It's not that bad. No questions? If you're not sure which course to choose for next year, come and see me. I won't sell you into advanced functions just because I teach it. We'll talk about what you want to do and we'll choose the right course for you. Yeah? Yeah, more questions? Find the number of terms in this geometric sequence. Ah! Don't get intimidated by these. When it says find the number, even if you don't know how to find the number of terms, step one, build the formula. At least do that. Two things. You'll at least get the marks for building the formula. And then maybe once you have the formula, you might be able to go, huh, how can I use this thing to find? So the formula is Tn equals ARn minus 1. The A is 3. I can see that by just looking at the sequence. A is the first term. And the R, because they said it was a geometric sequence, I only got to do this once. 6 divided by 3, which is 2. Tn equals A 2 to the n minus 1. There. Now I have the sequence. If you want to get any term in the sequence, you go 3 times 2, n minus 1 times. So this is term 1. This is term 2. This is term 3. And this is term question mark. Maybe you already know what it's going to be. It's question mark. What term is that? Well, to do that, I put the sub in, 384. I just sub in the 384 over there and go, I just got to solve this equation. Now, solving this equation is not easy, by the way. I got to show you some steps. First step's easy. Divide by 3. 384 divided by 3 is 128. I need to give you the big picture here. Grade 11U is a long course. There's a lot of stuff in it. And technically, there should be more in it. And there's something called logarithms. Have you ever heard that word, logarithms? It's used to solve exponential equations. It'll make them easy. But we don't do it till advanced functions. So here, we're sort of stuck with trial and error. We look at the 128, and we go, OK, 128. 2 squared is 4. 2 cubed is 8. 2 to the 4 is 16. 2 to the 5 is 32. 2 to the 6 is 64. And 2 to the 7 is 128. Do you have to do this? No, you could probably use your calculator and just trial and error, play around until you find out 2 to the 7 is 128. That's how you solve these in grade 11. You go, OK, well, what is 128? It's 2 to the 7. Therefore, n minus 1 is 7. N equals 8. That's a little bit difficult. I think the main difficulty grade 11s feel with this is that, so I just trial and error it, you feel like you're cheating or something. But at this point, that's all we can do. We will learn logarithms later. And those of you moving on to chemistry and biochemistry, some biology people, will definitely want to learn logarithms. And I'll teach them to you in advanced functions if you take that course. If you take chemistry, Mrs. Tile will teach them to you too, but only what she needs to get the answers. She won't go crazy with them. I'll do a whole chapter. Any questions on that one? No, please don't misunderstand. I'm glad to answer your texts and emails till your exam day on the 26th. And next semester, with whatever math you're taking, you can text or email me. That's fine. However, to grow, if tonight you text or email me, Mr. Todd, how do I find the number of terms in this geometric sequence? I'll be thinking in my mind, I'll be like, we've got to start looking at the notes. Because I'm not going with you to university or college. I'm not coming. Okay, I'm going to stay here. So at some point, you've got to get independent enough to be able to look through the notes and go, was this covered in the notes? Sometimes it's not covered in the notes. Most times it is, though, somewhere. How many more? Oh, this one. I love this one. Yes? Test hint. I love this question. Term 5 is 1875. Term 7 is 46,875. Find the first three terms. What? Well, let's write down the formula anyways. I wrote down something really important there. They told me, though, that term 5 was 1875. That means if n is 5, T5 is 1875. Sub that in. And something really scary happens. 1875 equals A R 5 minus 1. I'm trying to relate this back to yesterday's lesson. What is it that is so extremely scary about this situation? Two variables. When it happens for the rest of your math life, just label it number 1. Go, okay. Apparently that's not going to do it. Nobody can solve that. Mr. Todd cannot solve. I don't know what A and R is when I'm looking at two variables, one equation. A and R could be a lot of different things. But T7 equals 46,875. They gave me other information. What does that mean? Which means if T equals 7, T7 equals 46,875. I can put that in the formula, sub it in. Sub. Oh. Somebody feel like a sub. I got new Subway coupons too. I'm excited. 46,875 equals A R 7 minus 1. And again, just to say this out loud so you get used to it. Why is that equation so scary? Well, it's got big numbers, yes, but two variables. For the rest of your math life, just label it when that happens. Just go, okay, there's some information. Let me write these over top of each other. Therefore, 46,875 equals AR 6th. 1,875 equals AR 4. Ah. 2, 1. Those are the two equations. Now yesterday, when it was common difference, when these things were added, we subtracted the two equations. This is multiplying. What operation then might? It's not clear it's going to help. What operation might help? If yesterday when we were adding I used subtraction, should check division. Let's divide these two equations and see what happens. 46,875 divided by 1,875. Oh, the A's cancel out, and I get R squared equals, I don't care anymore what this is, because I'm going to be able to get it. Divide them. 46, does it come out to something nice? 25. 25. I'm so happy. I'm so happy. So what's R? Therefore, r equals square root 25 equals 5. Getting a little itchy here about something, but I'll get back to that in a second. So how am I going to get a?
You can do like either equation.
Yeah, just sub in. Sub in
Yeah.
r equals 5 into, I'm going to do equation 1, but it doesn't really matter. 1875 equals a times 5 to the power 4, which is 625. And when I divide that, I get 3. Love this job. Where's all the snow? Yeah, it's not happening. It's good. I'm glad. I'll go back if you need me to. I'm just going to write something else over here, okay? Therefore, Tn equals ARN minus 1 becomes Tn equals 3 times 5 to the n minus 1.
Mr. Shaw, what about like test rewrites? No, like, you know, 'cause yesterday you said that you.
Oh, yeah. Let me put that up here. Things to talk about after the lesson. Test rewrites, exam review, culminating, schedule, test day. Yes, all these things before I sit down on that desk. Yes? Okay. You're so happy. You're like, oh, I did it. I'm so smart. And you get it back, and it says 3 out of 5 marks. And you're like, what? Read the questions. Yeah, it's good. The more and more, as the algebra gets longer in these questions, it's easy to lose track of what the question was asking. I got the formula. It wants T1, T2, T3. So that was the first 3 terms?
Yeah.
So T1 equals 3 times 5 to the 1 minus 1. Term 2 equals 3 times 5 to the 2 minus 1. And term 3 is 3 times 5 to the 3 minus 1, which is 45. Okay? There. Answered the question. You get your test back. 4.5 out of 5. Oh, I got TN. Because it could be negative as well. Holy crap. Are you serious, Mr. Todd? Would you, in the middle of all this, put a plus minus in there? Well, I don't know that I would. That's not the point. You're moving on to tougher and tougher courses where these things could happen. Plus or minus square root. Plus or minus 5. As it turns out, you still get the same a value if you do plus or minus. Because if you go negative 5 to the 4th, you still get the same a value. So the only thing that really changes is term 1 could be 3, term 2 could be negative 15, and term 3 would be back to positive 45. You could get a sequence that oscillates between positive and negative there. Okay? I warn you about that, just in case it's the homework. I don't intend to trap you. Future teachers, here's what you do to avoid this problem. Don't make it squared there. Make it cubed, and then you don't have to worry about negatives. And you don't have to torture your beautiful grade 11s, okay? 5 out of 5 now. It's good. Any questions? Folks, this chapter is very popular for people who do their homework, but you can see, if you haven't done this, you're going to leave questions blank. There's no way you're going to get a great mark on a test if you can't do some of the key questions. I know, you're like,